Welcome to my channel Scienza Basica. Today I will be discussing about carbon and its compounds part 2. So we already know about the introduction of carbon and its compounds. Now let us come to what organic compounds are. So we know that carbon can form a huge number of compounds. It forms oxides, carbides, carbonates, hydrogen carbonates, as well as it combines with hydrogen and other compounds. Now particularly when carbon forms compounds with oxides, that is either carbon monoxide or carbon dioxide, carbon forms compounds with carbides, or carbon forms compounds with sulfates or other compounds, then we do not refer that as hydrocarbons. When carbon particularly combines with hydrogen, we refer that to a separate branch of chemistry referred to as organic chemistry. So we have carbon plus hydrogen referred to as hydrocarbons. Now, carbon is a unique element. We have got to understand about the electronic configuration of carbon, that is, it is 2,4, which indicates it is tetravalent. Carbon has a valency of 4, which means it can neither give nor take 4 electrons from other atoms, hence it shares electrons. Now this property of carbon, due to which it is tetravalent, itself implies that carbon can form a huge number of compounds. Now 3 types of compounds are being created. Now it is based on the type of linking about the carbon atoms. If the carbon atoms are linked straight chains are being formed. It looks somewhat like this. Okay. So straight chains are created when carbon atoms are linked side by side. Another type of linking of carbon atom is branched chain. Here we find branch chain of carbon atoms, and the third category is formation of either closed or ring chains. So this is how we find the 3 types of chains of carbon atoms. Now coming to the types of carbon compounds that are there. First we have hydrocarbons, that is the compounds of hydrogen and carbons, which we will be focusing on. Then we have the haloalkanes. Here we have the alcohols, aldehydes, ketones and carboxylic acids. Now coming over to hydrocarbons particularly. Now the compounds of carbon and hydrogen leads to a branch of chemistry referred to as hydrocarbons, that is organic chemistry. Now hydrocarbons we can further split up into 2 categories. The first category is the saturated hydrocarbons and the second the unsaturated hydrocarbons. So saturated hydrocarbons are the hydrocarbons which consist of carbon atoms linked by single covalent bonds, that is the sharing of electrons is just 1 pair. So let us have a look at how saturated hydrocarbons look like. Here we have carbon atom. We know that the atomic number of carbon is 6, which implies that it has an electronic configuration of 2,4. That is, carbon is tetravalent. So we have 4 valence electron in carbon. Now these valence electrons will be shared by some other compounds, some other atoms. Suppose we have hydrogen here. So 4 hydrogen atoms will share 4 electrons with carbon. So this sharing of electrons leads to covalent bonds. So this is how we find a particular saturated hydrocarbon. This particular hydrocarbon is referred to as methane, and this is the electron dot structure. Now when we come to the structural formula of hydrocarbon methane, then we can write it like this. And if we want the electron dot structure, it will look like this. Okay, so if we have a look, here we find that only one carbon atom combines with 4 hydrogen atoms to form methane. Such a huge number of hydrocarbons cannot be remembered or memorized. So there must be some structural formula or a general formula rather. Okay, so for alkanes, these kind of compounds are referred to as alkanes, that is, saturated hydrocarbons can be further categorized as alkanes. All the saturated hydrocarbons hence ends with ane. Hence, we find here the example that I gave you, methane, meth indicating 1 and it ends with ane indicates that it is an alkane. Now coming to the general formula for methane. Methane, that is a general formula for alkanes. Alkanes has a general formula of CnH2n plus 2, where N indicates the number of carbon atoms. So using this formula we can find out the formula for the other members of alkanes. So let us have a look at the other members too. So here let us come to the second member where carbon atoms is 2. So here we have C2H2 into 2 plus 2, that is C2H4 plus 2, that is C2H6. So this is how we can derive the formula of the second member. It indicates 2 means eth, and we know that all the members of the alkane series ends with N. So we get ethane. Similarly, we can find out for the third member where carbon atoms is 3. We have C3H2 into 3 plus 2, that is C3H6 plus 2, that is C3H8. Here 3 means prop, and all the members ends with N, so we will write down propane. In a very similar way we can find out for the fourth member. 4 means but, and N it will be butane, so it is C4H4 into 2 plus 2, that is C4H10. Similarly we can get pentane, hexane, etc. So this is all about the saturated hydrocarbons. Now let us come to the unsaturated hydrocarbons. Coming to the unsaturated hydrocarbons, we can categorize unsaturated hydrocarbons into 2 categories. First is the alkenes and the alkynes. Now what are unsaturated hydrocarbons? We find that carbon atoms, when they form compounds, the sharing of electrons takes place. When the sharing of electrons is either of 2 or 3 pairs, then triple or double bonds are created. Such kind of compounds will be referred to as unsaturated hydrocarbons. So what is the basic difference between saturated and unsaturated hydrocarbons? In saturated hydrocarbons, we found that only a single pair of electrons were shared, whereas in this case we find either 2 or 3 pairs of electrons are shared. Now in case of alkenes, here we find double bonds, that is sharing of 2 pairs of electrons takes place. Now let us have a look at the general formula for alkenes. It is CnH 2N. So in a very similar way as we have found out for alkenes, we will be getting the members for alkenes. So if the number of carbon atom is suppose 2, then what do we get? We get C2H2 multiplied by 2, that is C2H4. Now why did I start with 2? That is, here the carbon atoms should be linked with one another by double bonds. So it is mandatory that there should be the existence of at least 2 carbon atoms. So the first member itself will be C2H4. Here C2, we have already got to understand that 2 means eth. So we will be writing eth, and all the members ends with ene. So we will write down En, ethene. So let us have a look at the structural formula for ethene. So 2 carbon atoms will be linked by double bonds. The other bonds will be satisfied by hydrogen. So here already 2 bonds are satisfied. We are left with 2 more bonds. So this is how it will look like, C2H4. Similarly, have a look at the electron dot structure. Suppose this is how carbon looks like. The sharing of electrons will be 2 pairs. So this is the sharing of electrons, and this will be shared by hydrogen. Okay, so 2 pairs of electrons are shared here. Now coming to the third member. So if we come to the third member, there will be 3 carbon atoms. Okay, now we'll get H2 multiplied by 3, that is C3H6. Okay, so we have prop, and it will end with ene, so it's propene. Similarly for C4, that is, if there are existence of 4 carbon atoms linked by double bonds, we'll get but and ene, that is butene. Okay, so this was all about alkenes. Let us come to alkynes. These are hydrocarbons where the carbon atoms are linked to each other by triple bonds, that is, sharing of 3 pairs of electrons takes place here. It has a general formula of CnH2n minus 2. All the members of this series ends with yne, Y-N-E. Okay, so let us have a look at the first member. If we have C2, then we will have 2 into 2 minus 2, that is, we have C2H4 minus 2, that is C2H2. Okay, so let us have a look at the structure now. Carbon atoms are linked by triple bonds, and we have another hand to be satisfied. So this is how it will look like. Coming to the electron dot structure, here we have 3 pairs of electrons that are being shared, and the other electron will be shared with hydrogen. So this is the electron dot structure of eth and yne. Eth meaning 2 and yne, it ends with yne, that means it is an alkyne. So it is alkyne, ethyne. Now suppose if we have 3 carbon atoms, so it is C3H2 into 3 minus 2, that is C3H6 minus 2, that is C3H4. Okay, so we have the carbon atoms linked by triple bonds. Okay, and we have this one will be linked with hydrogen. We'll have this carbon atom linked with hydrogen. So this is how the third member will look like. So it will have prop meaning 3 and ine at the end, that means propyne. We have completed discussing the topic, and the next topic we will be discussing about the structure of molecules of alkanes, alkenes and alkynes. Thank you everyone and have a great day.